Hello seniors, today we're going to be having a kind of short class. It's related to arithmetic and geometric series. Remember when we talk about series, we're talking about the addition of all of the terms of a sequence, right? So what we're going to see today is electronic assignment number 9, which is sigma notation and series. We're going to see what sigma notation is. So the objective for today's class: apply sigma notation to find the sum of a number sequence. Okay, so it says adding the terms of a sequence gives a series. You already know this. U1, U2, U3, U4, and so on is a sequence, while U1 plus U2 plus U3 plus U4 and so on is a series. Okay, so that's the difference between a sequence and a series. Then it says the Greek letter sigma, called sigma, is often used to represent sum of values. So this is what we're going to concentrate our class on today, right? The sigma notation. So it says this symbol over here means the sum of the first n terms of a sequence. You read this as the sum of all the terms ui from I equals 1 to I equals n. Okay, you see that here we have a letter, right, which is I, which is kind of like the initiator of the sum. We may say that this I, we can define this I. If we define it as 1, we're going to say that we're going to add all the values from the first term, which would be U1, until term number n. So we're going to add plus U2, plus U3, plus, and so on until we get to UN. You see that if we, for example, defined I as, let's say, 3, what our calculator would do, or what we're supposed to do, is add from the third term forward. Okay, so we're going to add U3 plus U4 plus U5 plus and so on until UN. Okay, that's why I call this I the initiator, right? Because it may vary depending on where we want to start to find the sum of the terms. Okay, so that's how we interpret these symbols. So let's see an example. It says consider the arithmetic sequence 8, 14, 20, and so on. I already told you that this is an arithmetic sequence, so there should be a common difference between the terms. If you find the common difference, in this case, it will be 6, right? 14 minus 8 is 6. 20 minus 14 is also 6. So U1, the first term, is 8 in this case, and the common difference is 6. If I want to find UN, remember this is the formula for an arithmetic sequence. The formula was UN equals U1 plus n minus 1 times d, right? So that's what I'm doing here. U1 plus n minus 1 times the common difference. So if we plug in the values for this case, it will be 8 plus n minus 1 times 6. And if we develop this, we will get 8 plus 6 n minus 6. And finally, this would be our equation, which is 6n plus 2. Okay, so it says the sum of the first 5 terms is expressed as, and this is the notation, right? The sigma notation from 1, the initiator is 1 to 5. That means that we're going to add the first 5 terms of the sequence of this equation we wrote here, right? Which means the sum of all the terms 6n plus 2 from n equals 1 to n equals 5. That's exactly what we're going to do by performing this equation, right? So how do we do this? If we were supposed to do this by hand without using the calculator, this is the same as saying the following. So sigma notation from n equals 1 to n equals 5 is, and we're going to be replacing. Remember, the initiator is 1. So in the first case, n equals 1. Okay, so 6 times 1 plus 2, and we get a term over there which is 8, right? So this would be U1. Then U2 is 6 times 2 plus 2, we get 14. Then U3 would be 6 plus 3 times plus 2, which gives us 20, and so on. U4 is 26, and U5 is 32. So then, sigma means add all of the terms. So if we add all of these terms, 8 plus 14 plus 20 plus 26 plus 32, we get 100. So this equation over here equals 100. The sum of the first 5 terms of 6n plus 2 equals 100. That's how we interpret this symbology we have over here, which is basically adding all of the terms, right? So how do we do this using our calculators? I'm going to show you this quickly. If you have your calculators in hand, make sure you follow this. Okay, so this is the main screen of your calculator. What you're going to do is you're going to go to menu 1, which is the main screen, and you're going to click on math, which is F4. Then we don't see the sigma notation here, so you're going to press the little arrow there, F6, and there you see the sigma notation, which is F2, right? So you click on F2 and you get the sigma notation. So inside this parenthesis, we're going to put the equation, which is 6x plus 2, right? And then we need to define the initiator, which in this case we want to be equal to 1, so x equals 1 because our variable is x. If we wrote here n, we should write here n, but in this case we wrote x in both, so x equals 1. From x equals 1 to x equal 5, right? We went from the first term to a fifth term. And once we've done this, we click on execute, and there we get the result, 100. That means that the calculator calculated all of the terms and added them all together to get 100, okay? So this is the summary of the steps you need to follow in order to calculate the sum of the first 5 terms of this sequence, which is this screen over here. Okay, so let's see this example. Example 10 of the book. It says, write the expression, the sum of the first 4 terms of this sequence as a sum of terms. So for part A, we're going to write sigma notation from x equals 1 to x equals 4 of x squared minus 3. So without using the calculator, what are we supposed to do here? We need to add the terms from 1 to 4. So we're going to be replacing the value of x, 1, 2, 3, and 4, and then we're going to add all of the terms. So in the first case, it's 1 squared minus 3. That's the first term, plus the second term, which is 2 squared minus 3, plus the third term is 3 squared minus 3, plus the fourth term, which is 4 squared minus 3. Just in case you didn't get this, this would be u1, this would be u2, this would be u3, and this is u4. So we calculate all of these terms. Let me copy this a little second. So this would be there. This is equal to 1 minus 3, negative 2. 4 minus 1 is 4 minus 3 is positive 1. 9 minus 3, that's 6. And finally 16 minus 3, that's 13, right? Plus 13. So the result gives us, let me write it once again, vertical development. This gives us negative 1, 5 plus 13 gives us 18, okay? You may check this using your calculators if you want. Then for part B, it says calculate the sum of these terms. Okay, so we already did both things, right? For part A, we just had to do this. This is the answer for part A. Write the expression of the sum of terms, which is this. And for part B, we had to calculate the sum, which gives us 18. Okay. Then, example 11, it says, evaluate the expression, and we get this. The sum of the first, in this case, it's not the first 8 terms. It's from term number 3 to term number 8, right? Of this expression 2 to the power of a. So how do we evaluate in this case? We're going to write sigma notation from a equals 3 to 8 of 2 to the power of a. So this would be 2 to the power of 3. We're going to start with 3 because that's the initiator in this case, plus 2 to the power of 4 plus 2 to the power of 5 plus 2 to the power of 6 plus 2 to the power of 7 plus 2 to the power of 8. Okay, let's see if we can do this without a calculator. So if we duplicate this here, we're gonna have equal to 2 to the power of 3 is 8, then this is 16, 32, 64, then 128, one more, 256, right? Remember, this is like the memory of our cell phones: 8 gigabytes, 16 gigabytes, 32 gigabytes, 64, and so on. That's the characteristic of 2 to the power of any number. Okay, so if we add this should give us, the addition will be kind of tough here. Okay, I'm gonna do it with calculator, but just not waste too much time in this. This gives 64 plus 128 plus 256, 504. You can always check this by using the sigma notation in the calculator. 2 to the power of x, let's see if this is correct, x 3 to 8. Yes, 504 is the correct result. So I'm gonna put this down here. I'm gonna duplicate this to write the full answer. Okay. There you go. Then, example number 12, I think, yes, this is the last one. It says, write the series 3 plus 15 plus 75 plus 375 plus 1,875 plus 9,375 using sigma notation. Okay, so we need to do the opposite here. First of all, we need to identify what type of series is this. Is it geometric? Is it arithmetic? Neither. Let's see. So, U1, the first term, is 3, right? So 3. Then we need to check if it's geometric or arithmetic. So we're going to try first arithmetic. We're going to do 15 minus 3. This gives us 12. And 75. This is clearly not arithmetic, right? This gives us 50. So this is not arithmetic. Let's try if it's geometric. 15 divided by 3, this gives us 5. And 75 divided by 15, this is 5 as well. Yes, 5. So this is clearly a geometric series in this case, because we're adding the terms. Okay, so we know that U1 is 3, and now that we know that the common ratio is 5. So once we know this, we can express UN. Remember, the formula for geometric sequence is UN equals U1 times R to the power of n minus 1. This is available in the formula booklet in case you don't remember. So UN in this case is U1, which is 3, times R, which is 5, to the power of n minus 1. So this is our equation, our function, which we are going to plug into the sigma notation. So we want to find the sum of these terms, which are U1, U2, U3, 4, 5, 6, the sum of the first 6 terms of this sequence. So we're gonna use sigma notation and write sigma notation from n equals 1 to n equals 6, right? Of this equation, which is 3 times 5 to the power of n minus 1. And this is how we express this using sigma notation. And if you want, you can always try and see if your result is correct. So if you apply sigma notation, let's see, if I apply sigma notation of this 3 times 5 using a calculator to the power of x minus 1 from x equals 1 to 6, we're getting this number 11718. Then if you try adding all of these terms just using your calculator, you should get the same answer, right? 75 plus 375 plus 1875 plus 9375. And yes, if you add all of these terms, you get 11718. So this is correct. But this is not what the exercise was asking us for. We're just asked to find the sigma notation of this, which is what I just framed. Okay? So I hope there are no doubts about this. This is a kind of easy topic. I'm showing you this because I've seen some IB exercises which ask you to find the sum of the terms using sigma notation and not by applying the formula. So that's why I wanted to show you this, just to make it clear and for you to understand what the sigma notation symbol is about. See you.